Hi, welcome back to your new lesson. In previous lesson, I had shown you how you can fit a polynomial into your data using MATLAB figure window. In this tutorial, I am going to show you how you can do data fitting using MATLAB command or MATLAB functions such as polyfit and polyval. Polyfit finds the coefficient of a polynomial and polyval returns the value of a polynomial of degree n that was determined by polyfit to evaluate at x. So let's close this first, and once we close that window, we are going to create first a t data vector. So 0 and then 0 point, let's make it 0.3 and then 0.8 and then we are going to make it 1.1, then 1.6 and then 2.3. And in the similar way we are going to create here y. Okay, this is just a random data, 0.6 and then 0. Let's say 67 and then we are going to make it 1.1 and then 3.1 and then 1.47, let's make it 47 and then we are going to make it 1. Let's say 2.1. okay, and now let's plot this t and y. If you plot this t and y, make it shg, now you will see here. So let's close this window first. Now this is a plot, right? Now you can see here there are few data points such as this one, here, 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 here and here. Now we need to get a polynomial so that it can fit it, right? So it will make a very smooth data. It will make it very smooth plot. So let's do it. Let's do this fitting from here itself once again, from basic fitting. So once you start with the basic fitting, if you do the cubic fitting, you will find that it's not fitting properly. So we can remove this cubic fitting and then we can move to 5th degree polynomial fitting. But once you move to the 5th degree polynomial fitting, now you can see it's not fitting properly as well. Then we can move to the 8th degree polynomial fitting, but this says that the polynomial is not unique since degree is more than number of data points. So but here we cannot do 6th degree polynomial fitting. Alright, so the moreover what is happening here, so the number of data points are exceeding by the polynomial degree. So it's difficult to fit this data since the number of data is very low here while fitting this data and the variation is also very high. So it might not be able to follow this data. Even if we do the safe preserving interpolant, then we can find here how it is perfectly fitting this data. Or if we follow this spline, then you can also see that this is not following well. So in all the cases we can see here safe preserving interpolant is the best fit while fitting this data. Right. And if we go to show equation, then we can show it here, equation. So equation says that it is safe preserving interpolant. So it has performed so many interpolations and after that it has done a fitting. So we cannot get that equation. Right, so let's close this and I'll show you how you can fit this using equation. So P is equal to polyfit t and y, and we are going to fit with the 5th order polynomial. So once we fit it with 5th order polynomial, and now we can print here p, and now you can see here the equation's value. So it's a 5th order. This is the coefficients of the 5th order, 4th order, 3rd, 2nd, 1st, and this one is a constant value. Right, so Now what we can do, now we can evaluate this polynomial. Okay, so the y2 is equal to polyval, and once we write here polyval and into the t, now let's plot this y2. Now you will see here this is y2 which we had evaluated based on our fitting. Now we are going to get residue, so the residue can be get here y minus y2. Now we are going to plot residual here. So this is a residual, and the residual you can see it's very low. Now we are going to plot our y and y2 together, so that you can get a little more information about how this data fitting has been done. Now as you can notice from here that this has follows exactly the same